Good afternoon, everyone. Today we're going to do a video on algebra with rational terms. And by that, all I mean is terms with a denominator, okay? So when we have an equation that looks like this, oftentimes it can be tricky to know where to start. If we start isolating each term by writing it like something like 4x over 3 plus 7 over 3 minus so on and so forth, it can get a little messy. We often have to deal with fractions, denominators, common denominators, and all that stuff. And it can be a bit of a mess. It's not the end of the world, it's not impossible by any means. It simply often becomes more work than it could be if we used maybe wiser strategy. And that's what I want to talk to you guys about today. So whenever we have an equation like this, where every term is rational, that means every term is in a fractional form, what we are best off to do is to start by looking for the common denominator of all of these fractions, okay? Or in another sense, the least common multiple of each of the denominators, that is to say the smallest number that is a multiple of all the denominators, okay? Now for us, the least common multiple, LCM, of 3, 4, and 6, if you want to take a second to think about it, the smallest number that is a multiple of all 3 denominators happens to be 12. Okay, I'm running like this because this is something we're going to see in grade 10, and so maybe this will give you tiny introduction into something you're bound to see later on, if you're a little bit more comfortable when you do see it in class. And so with this information in hand, the LCM of our 3 denominators is 12, and so what we're going to do is we're going to multiply every term in our equation by exactly that number, by the LCM of 12, okay? And what that's going to do is, since it's a multiple of each of the denominators, it's going to cancel out the denominators. Then it's going to give us an additional multiple up top, but we can handle that. We don't so much mind big coefficients. What we typically don't like is fractions along the way, because then we have to deal with common denominators and it can get us into some pretty messy calculations, okay? And we can easily avoid those messy calculations by doing this step at the very start, okay? So with that in mind, let's go ahead and multiply each term, or if you'd rather think of it, we can multiply both sides by 12, okay? So if we multiply both sides by 12, right, remember when we multiply an entire bracket by a number, that number by distributivity hits every term inside the bracket, right? So we're going to multiply every term by 12. And same thing on this side, times 12. So now let's go ahead and do that. If we multiply 12 by 4x plus 7 over 3, we can simplify first. So the 12 over the 3 is going to simplify down to 4. So let's go ahead and write that out a bit more clearly so we can see how it happens. So we have 4x plus 7 over 3, and then we have times 12. This is just one way of writing it. You could also write a 12 in front of it, right? That means 12 times everything inside the bracket. However you'd rather write it, by all means go ahead. This is probably how I would go ahead and write it. And next we have minus that entire term, and so we'll have minus 12 times, because the 12 multiplies each term, right? So minus 12 times 3x plus 1, all over 4, okay? Make sure you don't forget your negatives. It's always easy to forget our subtraction and our negatives, so be very mindful of that. And on the other side, we have 5x plus 2, all over 6, and we have that times 12. Again, there's no difference, times 12 or a 12 in front means exactly the same thing. However, it kind of feels right to do in the moment. And so now let's go ahead and simplify. So we have a 12 times the numerator, but divided by 3. So much how we can simplify fractions, we can simplify fractions that have expressions inside of them, all the same, okay? So let's simplify 12 over 3. That'll go to 4 over 1, and the denominator of 1 is redundant, and so we don't even have to write it, right? So just 4. Next we'll have 12 over 4 becomes 3 over 1, and again 1 in the denominator is redundant, so we don't need to write it. And likewise at the end, 12 over 6 will simplify to 2 over 1, let's not write the 1, and so there you have it. So now we can see that by multiplying every term by the LCM of 12, as we expected, we got rid of all of our denominators. Now we have no more denominators, and now our equation will be much easier to solve. Let's go ahead and finish off the multiplication by the new scale factor at the front. So we have 4 times 4x plus 7. Again, the 4 hits each term. So the 4 hits the 4x and the 4 hits the 7. And so 4 times 4x starts us off with 16x plus 4 times 7 means 28. Next, minus, let's keep our brackets because we're subtracting this entire term. So let's not get lazy with our subtraction. Let's keep the brackets so that we know we're subtracting the entire thing. Okay, it's so easy to make mistakes with subtractions and negatives. So now we're going to subtract 3 multiplies the entire bracket. So the 3 multiplies the 3x and the 3 multiplies the 1. And so we get 9x plus 3. And on the right side of our equation, we have the 2 that multiplies the entire bracket, and so the 2 multiplies each term. 2 times 5x means 10x, and 2 times 2 means plus 4, okay? There we have it. So now we're done with brackets, we're done with denominators, we have no more fractions. We can simplify our equation a tiny little bit before we start solving anything. So we have 16x minus 9x. Let's write those together. I like writing like terms together. So we have 16x minus 9x plus 28. Remember, this subtraction is for the entire bracket, so we're subtracting 9x, and we're subtracting that 3. And so we're going to subtract 3. Okay, that's what I mean by always being mindful of your subtractions with brackets. And we have equal 10x plus 4. Now we're almost ready to solve. So we have like terms, 16x minus 9x is 7x plus 28 minus 3 is 25. And again, we have equals 10x plus 4 plus, or excuse me. Now we're almost done, but we have a variable term on both sides. We know to solve this equation, we need to get them all on one side. I like to have positive coefficients, and so since the 10x is greater than 7x, let's subtract 7x on this side to get rid of 7x, and subtract 7x on this side. I'll do the same thing on both sides. So now the left side has only the 25 equals 10x minus 7x leaves us with 3x, and there's still the plus 4 at the end. And now we're back to a level 2 equation that we saw in grade 7 and grade 8. So we want to isolate the term with the variable. Let's get rid of the plus 4. And so the inverse operation means subtract 4, and so 21 is equal to 3x. And now we all know how to finish that one off. To get the value of x, we divide by 3, we divide by 3, and we find our solution that x is equal to 7. Okay? Which was probably not at all obvious looking at the monstrosity we start off with, but if we do take the time to multiply through every term by the LCM of the denominators, our lives become significantly easier with the rest of our equation, okay? So always look for the LCM of the denominator, no matter how complicated the expressions get. Even if the expressions begin to include some algebraic expressions, it's still wise to start off by multiplying everything through by the LCM so that we're no longer working with rational terms, which just means fractions, okay? So I hope this was helpful. I hope this cleared some things up. I hope this gave you a nice template for how to attack these kinds of questions. If you have any suggestions for future videos, please do let me know, and thanks for watching.